Good afternoon, ladies and gentlemen. So we are in Notes for 31A, Day 2. And what we're going to do right now is the vertical line test. So last week, we learned how to tell if something is a function by looking at a table. So we look at our table, and we look at our inputs, which are our x values, to see if any of the x values go to more than one y value. So if you remember the vending machine, if I input a certain x, I need to know which candy bar I'm getting. I need to know what the output's going to be. So we did that last week. So this week, the question is, what if instead of a table, what if it's a graph? Is there an easier way to do it? And the answer is yes. We have something that's called the vertical line test. If a vertical line crosses the graph of an equation only once, then it is a function. So if we look at the one on the bottom, notice that it's a line, and notice that the vertical blue line only crosses the red line one time, right here. So it passes the vertical line test, and it is a function. Now look at the one on the right. When I draw a vertical blue line, it crosses the red line, or the red curve, I should say, in two places, right here and right here. So it fails the vertical line test. It is not a function. Now, last week when we did this PowerPoint, we saw that this y equals 2x is a function. Every x has just one y. So if I push -2, I know I'm going to get candy bar -4. If I push -1, I know I'm going to get candy bar -2, and so on. Now, the new piece of information here is, what does it make when we draw the graph? And it makes a diagonal line. So if I draw a vertical line through my red line right there, notice it only touches it in one spot, right here. So it is a function. It passes the vertical line test. And we already knew that it was a function based on what we saw last week. Okay, now last week in the PowerPoint, these are the last two that we did. So the first one we knew was a function. Yes, it is a function, because if I draw a vertical line, it only touches it in one spot, right here. That's it, just touches it in one spot. Now look at the second one, not a function. It touches it in two spots, right here and right here. So that one is not a function, and we got that last week when we looked at the tables. Okay, now we have some examples. So the first one, if I draw a vertical line, it's only going to touch it once. It is a function. And there's the equation, y equals 1/2 x plus 2. Okay, this one, if I draw a vertical line, it is only going to touch it once. It is a function. And the equation is y equals 4. Now, pay attention to that, if you will. When the equation is y equals, and there's no x, it is a function, and it's a horizontal line. Now look at the next one, and notice that it's a vertical line. Well, if I do the vertical line test, oh no. Notice my blue vertical line hit my red line everywhere, in every single spot. So if my blue line touches my red line more than one time, then it's not a function, and it touches it a ton of times. So it is not a function, and the equation is x equals 5. Now let's back it up a minute. When the equation was y equals, it was a horizontal line, and it is a function, because a vertical line only touches it once. When the equation is x equals anything, it's going to be a vertical line, and it is not a function. Now we go to the fourth one on the top. If I draw a vertical line, it's only going to touch it once. It is a function. Now come down to the bottom row. If I draw a vertical line, it touches it twice. Not a function. Okay, next one. If I draw a vertical line, it only touches it once. It is a function. Next one. If I draw a vertical line, oh no, it touches it more than once. It's not a function. And then finally, the last one, a circle, if I draw a vertical line, it hits it twice. It's not a function. Okay, now we have some more examples, and 3 of them are either a table or mapping. So the first one, if x is 0, y is 5, x is 1, y is 5, x is 2, y is 5, x is 3, y is 5. This is a function. Why is this one a function? This is like the one that we did last week with the Twix bars. Remember how we said that they had too many Twix bars, so they put them in 3 different rows in the vending machine? If I punch 0, I know that I'm going to get candy bar 5. So 0 is good. I know when I punch 0, I get candy bar 5. If I punch 1, I get candy bar 5. If I punch 2, I get candy bar 5. So the candy bar that I get is a function of the button that I push. Each x only goes to 1 y. It's allowed. So even though they all go to 5, that's okay. Remember that the y value can happen more than once. It's the x value that can't. So number 1 is a function. Okay, now look below and look at number 2. When x is -3, y is -1. When x is -3, y is 0. When x is -3, y is 1. When x is -3, y is 2. Okay, this is a problem. Because now, if I punch -3, there's 4 different candy bars I could get. There's multiple outputs for one input. It doesn't work. It is not a function. Number 3, if I draw a vertical line, it's going to hit it in 3 different spots. It's not a function. Number 4, -2 could be 3, -2 could be 4. Okay, when I punch -2, I don't know if I'm going to get candy bar 3 or candy bar 4. Therefore, it is not a function. Okay, this one's really interesting. I want you to notice that there are closed circles everywhere, and a closed circle is a point on the graph. So if I draw a vertical line, it touches twice. It's not a function. Okay, now look at the next one, and do you notice it's almost exactly the same? The only difference is, instead of the closed circles we had over here, they're open circles. If they're open circles, then those are not points on the graph. An open circle is not a point on the graph. So if I try to draw the same vertical line that we drew on the other one, so if I go draw the same vertical line, it actually never touches the function at all because it's going through 2 open circles. So that's fine. Okay, if I draw it here, it only touches once. That's fine. If I draw it here, it only touches once. If I draw it here, it only touches once. This is a function. So the fact that we changed them from closed circles to open circles made it different, and it is a function now. Now, this is not important for you right now, but it will be important for you later on. Open circles are not a point on the graph. Now, you might ask, so we learned today about this vertical line test. Is there a horizontal line test? The answer is yes, and you're going to learn about it in later math classes. Okay, now we're going to leave the PowerPoint and we're going to go to My Open Math, and we're going to go to Notes for 31A, day number 2. Notes for 31A, day number 2, and we're going to start. So number 1, we're going to do 1, 2, and 3 together, and then you're going to do 4 through 6. If you are given a graph, the previous definition given in the last lesson still applies. But there's an easier way to see if a graph is a function. Vertical line test. If a vertical line crosses a graph in only one, okay, everybody put your cursor in the box and type 1, O-N-E, one spot everywhere on the graph represents a function. Type 1 and then submit. Now what comes up is an example. So if you look at our first example, our vertical dotted line only touches the graph once. Therefore, it passes and it is a function. Now look at the second one, and the writing is in green now. The vertical line touches it twice. So there are 2 outputs for one input. It is not a function. Now go to the right and look at the one in blue. Notice again, this oval, it touches it twice. So there are two outputs again, not a function. Okay, do we understand? Type yes and then submit. And now you're ready to go on to number 2. On number 2, what we're going to do is we're going to just look at the graph and make a decision. So if I draw a vertical line, it only touches it once. So yes, it's a function. Okay, go across, draw a vertical line. Uh-oh, you guys, it touches here and here and here. Not a function, don't select it. Okay, now go down to the next one on the bottom left, or the middle left, I should say. Vertical line only touches it once, just right here, so it's good, it's a function. Now draw a line here. Okay, we're good, it only touches it once, it is a function. Now draw a line here. Okay, it only touches it once, it is a function. And now draw a line here. Uh-oh, it touches it twice. It's not a function. Okay, so now you want to pause the video and you want to go to your My Open Math screen. And on the left, you want to select all 3 of them. And then on the right, you want to select the middle one. So you want to select all 3 of them on the left. And then on the right, you want to select the middle one. And then you're going to submit and move on to number 3. Okay, number 3, we're going to do the same thing that we did a minute ago. We're going to draw a vertical line. It only touches it once. Yes, it's a function. We're going to draw a vertical line. It only touches once. Yes, it's a function. We're going to draw a vertical line. It only touches it once. Yes, it's a function. We're going to draw a vertical line. Okay, hold on one second. If I draw my vertical line right there, I want you to notice that, hey, that only touches once. It passes. However, if I draw it here, see how it now touches 1, 2, 3 times. So it's exactly like what we've learned before, where if you want to prove that something is a false, you only need one counter argument. So it doesn't matter if there's someplace that you can draw a vertical line where it passes. If it fails anywhere, then it is not a function. Okay? Not a function. Okay, now we're going to draw here. Now these are kind of weird, the last 2. So I got to check everywhere because they're not connected. Uh-oh, that's a problem now, because do you see how I hit 2 of them in one vertical line? Not a function. Okay, now I'm going to do the same thing here. Okay, I try that one, that works. That one works. That one works. That one works. And that one works. Okay, all of them worked. Yes, it's a function. Okay, now you're going to pause the video and you're going to go to your My Open Math, and on the left side, you're going to select the first one and the second one. And on the right side, you're going to select the first one and the last one. So we're going to select this one, and we're going to select this one and this one. And then you're going to submit. And you're going to go on to number 4. Okay, now what I'd like you to do is pause the video, and I want you to select all of them on number 4 that you think are functions. And when you're done selecting, don't submit it. Then come back and watch the video. Okay, so I'm assuming that you watched the video you paused the video, you selected all the ones that you think are functions, and now you're back to the video. So this one, I hope you selected yes, it's a function. It only crosses that vertical line once. Okay, this one, I hope you said not a function. I hope you did not select it. Okay, this one, it passes there. It passes there. it passes there, it passes there, and it passes there. So yes, it's a function. Okay, this one only touches it once. Yes, it's a function. Okay, this one only touches it once. Yes, it's a function. Now, if I draw my vertical line right there, it passes. But if I draw my vertical line there, it fails. So remember, if it fails anywhere, it fails. So I'm hoping that on the left side, you got the first three on the left, all of them are functions, and on the right, just the one in the middle is a function. So function, 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 and submit. Okay, number 5, do the same thing. I want you to pause the video, see if you can figure out which ones are functions, and then start the video again. So now that you've started the video again, not a function. Yes, it's a function. Yes, it's a function. Not a function. Yes, it's a function. Yes, it's a function. So on the left side, the middle one and the bottom one, and on the right side, the top one and the bottom one. I hope that you got it right. So this one, this one, this one, and this one. And submit. Number 6. Okay, same thing. Pause the video, do them, and then unpause and see if you got them right. Okay, so I'm assuming that you paused it, you did them, and now you're checking. Yes, it's a function. A vertical line will only touch it once. Yes, it's a function. A vertical line will only touch it once. This is back to the tables that we did the other day. 5, 6, 11. Yes, every input has one output. If I punch 11, I'm going to get candy bar 7. I know what candy bar I'm going to get. Okay, this one, 5, 6, 11. Yep, it's all good. I know what candy bar I'm going to get. This one, 5, 6, and 6. Uh-oh. So if I punch 6, I don't know if I'm going to get candy bar 7 or candy bar 12. Not a function. Submit. Okay, number 7, this is one that we did. No, this is new, sorry. So this is a new idea where it says, okay, I'm giving you a graph, and I'm going to give you the input, and I want to know what the output's going to be. So if I give you the input of -1, I want to know what the output of the function is. So the input is the x value. So when I say that x is -1, you have to remember that the x-axis is this one, the one on the side, and then the one that goes up and down, that's the y-axis. So if I give you that the input of the function is -1, see where it says that right up here? The input is -1. So I go to where x is -1 right there. Now, do you notice that I'm not touching the red line? Well, in order to find the output, I have to touch the red line. So to get to the red line, staying on -1, I have to go straight down. And then what number am I at? I'm at -2. So when x is -1, y is -2. Okay? So type -2 and then submit. -2, submit. Okay, number 8. Okay, same thing. We have a graph, and they gave us the same input. So the input is -1. So remember that the input is the x. So we go to where x is -1 right there. And remember that we have to stay on -1. We can't move away from the -1. So I have to go straight up or straight down. Well, if I want to hit the red line, I've got to go straight down. So I go straight down till I hit the red line, and look, I'm at -5. So when the input is -1, the output is -5. And another way to say that is when x is -1, y is -5. When the domain is -1, the range is -5. Okay? So now we type -5 and submit. Okay, now what I'd like you to do is I would like you to see if you can do this one. So this one says that the input is 3. Remember that this is your x, and you always want to go to your x. Your input is your x. So what I want you to do is pause the video, go to where x is 3, okay, figure out what the y is, and then don't submit it. Start the video again to see if you're right, okay? Okay, so now I'm assuming that you stopped the video, you went to where x is 3. Now remember, we have to go straight up or straight down, and if I want to hit the red line, I have to go down. So I go down to here, and I have to go across. What number am I at on the y-axis? I'm at -7. So hopefully you got -7. If you did not get -7, do you understand? If you don't, you need to talk to me. Okay, type -7, submit. Okay, number 10 is another one for you to do. Pause the video. The input is 2. Okay, so I'm assuming that you paused the video and you've done it, but you didn't submit. So remember that the input is the x, so we go to where x is 2, and remember that we want the y. And the y, remember, is the up and down. And remember, if I have to stay where x is 2, I can only go straight up or straight down. So I go straight up because that's how I hit the red line. And look, I hit it right here. What's the y? The y is 3. So I'm hoping that you got 3 when you did it. So when the input is 3, when the input is 2, the output is 3. Submit. Okay, number 11, this is what we did last week. So I'm going to click over here to add work, and I'm going to type y equals mx plus b, space, 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 m equals slope, space, 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 b equals y-intercept. Okay, pause the video and type those into your My Open Math. Okay, now that you're back to me, our equation is y equals -1/5 x minus 4. So enter y equals -1/5 x minus 4, space, 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 m equals -1/5, space, 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 b equals -4. Okay, pause the video and type that in. Now, when you graph a line, you always start with the y-intercept. And the y-intercept is the -4. And the y-axis is the one that goes up and down. So we're going to put a dot at -4. Now we go to the slope, which is the m, and that's -1/5. So we have to go down 1, right 5. Down 1, right 1, 2, 3, 4, 5. So the top number is always what you go up or down. The bottom number is always what you go right. If it's positive, you're going to go up and right. If it's negative, you're going to go down and right. Submit. Okay, pause the video and see if you can do this one on your own. Okay, now that you're back, y equals mx plus b. So the b, the y-intercept, is 4. So we put a dot, the y-axis is the up and down, put a dot at 4. Okay, our slope is 4 over 5. So it's positive, so we're going to go from our dot, we're going to go up 4 and right 5. And then submit. Okay, this is a review of ones that we did last semester. So the first thing that you need to do is find your slope. So we make our slope triangle, okay? So we find a perfect point. I'm going to find one right there. And then I find another perfect point, and I find one right there. And I make my slope triangle. Now, I went down 1, 2, 3, 4, and right 1. So down 4, right 1 is negative 4 over 1, but negative 4 over 1 is the same as negative 4. So I can put negative 4 over 1, or I can just put negative 4. Okay, now we need part B. We need the y-intercept. So we need the point where our line, our red line, hits the y-axis. The y-axis is this one that goes up and down. So if you look, our red line hits the y-axis at 3. So we type 3. And then our equation is y equals mx plus b. So y equals, okay, our m is negative 4, x plus 3. And then we submit. Okay, number 15 is interesting. So we have our table. So we have 2, 6, 10, and 14. And then we have 16, 36, 56, and 76. Okay, so the first thing that we do is we look at our y's and we say our y's changed by how much? So 16 to 36, isn't that up 20? So the y's changed by 20. And then the x's went from 2 to 6, and so didn't they go up 4? So the x's changed by 4. Now remember that your slope is the change in the y's over the change in the x's. So it's going to be 20 divided by 4, but that reduces to 5. So now we're going to type them in. So our y's changed by 20, our x's changed by 4, and then our slope was 5. Okay, so now look at this one. So our table is 4, negative 15, 9, negative 40, 14, negative 65, 19, negative 90. Okay, our y values went from negative 15 to negative 40. Oh my goodness. How many was that? Okay, well, it's going down. So I'm going to count by 5s. Starting at 15, 20, 25, 30, 35, 40. So I counted 5 5s. 20, 25, 30, 35, 40. So it went down 5 5s. Okay, 5 5s is 25. So it went down 25. Now, how do I know it went down? Because negative 15 means like I owe $15. Negative 40 means I owe $40. I owe more money than I owed before, so I borrowed more. So my y's went down 25. Okay, my x's went from 4 to 9. Okay, count from 4 to 9. 5, 6, 7, 8, 9. That's 5, right? 4 plus 5 is 9. So my x's went up by 5. Remember that your slope is the change in the y's over the change in the x's. So it's negative 25 divided by 5. Okay, negative 25 divided by 5 is negative 5. So now we put in negative 25, and then we put in 5, and then we put in negative 5. Okay, now pause the video and see if you can do this one. Okay, so now you're back. The y's went up by 10, right? 24 to 34 is up 10. The x's went from 4 to 6, so they went up 2. The slope is the y's over the x's, so 10 divided by 2, so the slope is 5. So 10, 2, and 5. Okay, and we are done with the notes for 31A, day 2. Have an awesome rest of your day. Bye-bye.